Welcome to C.M.P lab. In this class, we are going to see how to solve some questions on indices. Alright, so this question says evaluate 2 raised to the power of x equal to 32. Alright, now first, remember that in this question what we are going to look for is x. What's the value of x? To what number will 2 be raised to for us to have 32? What number will 2 be raised to so that we have 32? This is what the question is talking about. Okay, but for you to proceed with this question, okay, you have to write 32 first in its index form. Okay, so let's go. Okay, so 2x, 2 raised to the power of x, 2 raised to the power of x, and the index form of 32 is 2 raised to the power of 5. Okay, because 2 times 2 times 2 times 2 times 2 will give you 32. Okay, yes, all right. So the bases now are now equal. Okay, so we equate the base, we cancel the bases. Okay, and we have x equal to 5. Okay, x is equal to 5. So 5 is the value 2 must be raised to have 32. So we can check that. You can check that. Okay, all right. We say that, we say 2. Remember, our x is equal to 5. Okay, so this is, put 5. All right, so that this is 32. And remember that this is 2 times 2 times 2 times 2 times 2. Okay, so that 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 is 32. So we have 32, we have 32 is equal to 32. Okay, let me put this clearly. Times 2 times 2 times 2 times 2. Yeah, yeah. Okay, okay, we'll go to the next question. It says number 2 says simplify 3 raised to the power of 2x equal to 81. Okay, so this question actually means, okay, to what number will 3 raised to the power of 2 be multiplied with, okay, to have 81. That is what it simply means. Okay, so but to proceed with this, we have to put everything in its index form. Okay, we have to put 81 as well in its index form. Okay, so we have 3 raised to the power of 2x equal to, the index form of 81 is 3 raised to the power of 4. Okay, 3 raised to the power of 4. All right, so now the bases are equal, so we cancel this. Okay, this is gone. All right, so we have 2x equal to 4. All right, we cancel because we are looking for the value of x, remember, so we cancel 2, we divide 2 by both sides. Sorry, we divide 2 by both sides. All right, so that x will stand alone. So 2 cancel itself, 1 cancel here, 1, 2 divide itself, 1 goes into here, 2. All right, so x is equal to 2. All right, so we come to the next question. The next question says simplify 9 raised to the power of x plus 2, which is equal to 729. Okay, all right, so solution. First, remember that we have to write everything in its index form. Okay, so if we write 9 in its index form, this is 3 raised to the power of 2. Remember the algebra on top. Okay, bracket 2 bracket x plus 2 bracket close equal to, writing 729 in its index form is 3 raised to the power of 6. Okay, yes. So now you see now that the bases are equal, we cancel off the bases, so that we are left with 2 bracket x plus, we are left with 2 bracket open x plus 2 bracket close, equal to 6. All right, so we multiply, we open the bracket. 2 times x is 2x. 2 times plus 2 is plus 4, which is equal to 6. All right. Okay, so we collect like terms from here. We have 2x equal to 6 minus 4. Okay, so 2x equal to 6 minus 4 is what? Is 2. 6 minus 4 is 2. Okay, all right, so we cancel 2 so that x can stand alone. We divide 2 by both sides. 2 cancel 2, 1. 2 cancel itself, 1. 2 cancel here, 1. Okay, so this is x. Remember, 1 divided by 1 is 1. X is equal to 1. All right. Okay, but we can as well check this, okay, if we are actually correct. Okay, we can check this to see if we are actually correct by substituting 1 for x in our question. All right, so we can substitute x. Okay, we can substitute 1 for x. Okay, so if we take this, all right, 9, take 9. Okay, we put the 1, x is equal to 1. We put 1 here. 1 plus 2, okay, which is equal to 7 to 9. All right, so that 1 plus 2 is equal to 9 raised to the power of 3. 9 raised to the power of 3. Okay, 9 raised to the power of 3 equal to 7 to 9. All right, and 9 raised to the power of 3 is 9 times 9 times 9. Okay, and 9 times 9 times 9 is equal to 7 to 9. Okay, so you can see that what is in this side of the equation is as well equal to what is on this side of the equation. What is on the left hand side is equal to what is on the right hand side. So the answer is actually correct. Okay, let's go to the next question, number 4. The number 4 question says, if a and b are whole numbers such that a, okay, raised to the power of b is equal to 1 choose 1, that's 121. Find the value of bracket open a minus 1 bracket close raised to the power of b plus 1. Okay, but now take a look at this equation. A raised to the power of b equal to 121. Look at this equation closely. You see that if we want to apply all of our rules we have been using, all of the methods we have been using, okay, that if we should write 121 in its index form, it will be 11 raised to the power of 2, because 11 times 11 is 121. Okay, so if we say take this equation, okay, we can write this as this. You can see now that this expression is in this form. Okay, this 11 raised to the power of 2 is in the form of a raised to the power of b. Okay, and they say that a, okay, that, and you can see that a is equal to 11 and b is equal to 2, because the question says if a and b are whole numbers such that a raised to the power of b, okay, a raised to the power of b, that's a number, okay, raised to the power of a certain number is equal to 1 to 1. Find the value of this, okay, this mathematical statement. All right, so from here we can see that a is equal to 11, all right, and our b is equal to 2. Okay, now we come back because this is now the main question. Find the value of bracket open a minus 1 bracket close b raised to the power of b plus 1. Okay, now this is the main question here. All right, so what we are going to do, we are going to substitute the value of a and b in this mathematical expression. Okay, here. All right, So substitute, okay, the values, the value of A and B, okay, respectively in the expression. All right. So our A is equal to 11. Okay, 11. Our 11 minus 1. Our B is equal to 2 plus the 1 here. Okay, so we proceed with solving this. All right, we will add this 11 minus 1, 2 plus 1 is 3. All right, and we solve what is inside the bracket. We say 11 minus 1, this is 10. So this will be 10 raised to the power of 3. Okay, 10 raised to the power of 3. Okay, all right. So which is equal to, we say, all right, remember the product power rule. If you have a number raised to a power enclosed in a bracket like this, what you do, you use the power to multiply with the power of the number. Okay, remember that this 10 is raised to the power of 1, but we don't usually write it. It's not usually written. Okay, so if we say 3 times 1, okay, it will be equal to 3. Okay, any number you see written, okay, whether it's 2, okay, whether it's 3, whether it's 4, whether it's 5, all are raised to the power of invisible 1. Okay, the 1 is not always indicated. All right, okay, so we say that this is 10 raised to the power of 3. Okay, all right, we should know that 10 raised to the power of 3 is 1000. Is equal to 1000. Okay, we go to the next question. The next question says, the number 5 question says, simplify, parenthesis open, 5a raised to the power of 5 b raised to the power of 2 times 3, bracket open, a b raised to the power of 3, bracket close, raised to the power of 2, parenthesis close, divided by, bracket open, 15a raised to the power of 2 b, okay, bracket close. All right, you know that this expression, to proceed, you know that this expression can as well be written like this. Okay, 5a raised to the power 5a raised to the power of 5 b square times, okay, 3, bracket open, a b q, bracket close, 2, parenthesis close. All right, all over, okay, all over 15 a raised to the power of 2 b. Okay, all right, we look at this question closely. It's advisable, or you always, okay, whenever you have multiple enclosures like this, okay, in a mathematical expression, you always start with the inner enclosure, okay, to solve. All right, always start with the inner enclosure to solve. Okay, so if we come to this, you can see this enclosure, this bracket, ab raised to the power of 3, bracket close, square. All right, so looking at this enclosure, considering this first enclosure here, all right, so what rule can be applied here? There's a rule we call the product power rule. Okay, that rule simply says that if you have, for instance, if you have multiple if you have multiple if you have multiple numbers like this, or algebra like this, what do you do? Okay, which is enclosed and raised to a power, what do? You use the power, okay, to multiply with what is inside, okay, the bracket. You use the power outside to multiply with the powers of all the values inside the bracket. Remember, all of these values are raised to the power of 1, 1, 1, 1, 1. Okay, so this is simply 3 times p raised to the power of 1. Okay, the invisible one, this is 3. Okay, 3 raised to the power of q. Okay, all right. 3 times q raised to the power of 1 is 3. Okay, times this is r cube, then this is s cube. Okay, so this is simply what the law talks about. Okay, all right. Okay, so if we do say, okay, from the product power rule for here, all right, we have 2 times a, okay, 2 times a, 2 times a raised to the power of 1. Okay, you know that a is raised to the power of 1. Okay, so this is 2 times 1. Okay, a raised to the power of 1. Okay, all right, and 2 times 3, okay, will give us 6. Okay, so we have done with that. All right, so the next thing is to consider, we consider, look at the algebras. Okay, you notice that here and here are common in that they have the same base. Okay, but let's first work with this enclosure, work on this enclosure, because we have to open the bracket. We have to finish with everything, enclose the inner enclosure first before considering anything else. All right, so we have that this is equal to 15 raised to the power a raised to the power of 2b. All right, so that we have that, 5a raised to the power 5a raised to the power 5 b square times 3 times a square b raised to the power of 6. Okay, so this is simply equal to 3 times 3a raised to the power of 2 b raised to the power of 6 all over 15 a square b. All right, okay. Okay, so looking at this, you can see here that the bases are the AB. We have AB here, AB here. Remember the step we usually consider. Okay, that we have to split the algebra. Okay, we have to separate the alphabet from the numbers so that we can proceed with the solving. All right. So if we have 5, okay, 5, we have 5, okay, times 3. Remember that the operation here, okay, the operations here are multiplications. All of the operations that is binding this algebra, okay, is multiplication. Okay, so we have 5 times 3, okay, times 5 times this 3 times, put the bigger times, which is a raised to the power of 5, okay, times b raised to the power of 2 times a raised to the power of 2 times b raised to the power of 6 all over 15 times a raised to the power of 2 times b raised to b, okay, times b. All right, so you can see here, we can still as well arrange this. Okay, can still arrange this and say we bring the a's closer. Okay, so we have this. All right, so we have this, and we bring the b's closer. Okay, with the b's closer. Okay, All right. All right. Okay. So that we have um okay, sorry, we bring the b. Okay, it's a b raised to the power of 2 here, b raised to the power of 2. Okay, all right, so that all over 15 equal to here. Okay, so 5 times 3 is 15. Okay, all right, we apply the multiplication rule here. Okay, so this will be we take it a common base and add the powers. Okay, so we have a raised to the power of 7. All right, we add this, we take it a common base, we add their powers, so b raised to the power of 8. All right, all over. Okay, all over. All right, we should have splitted this so that we have 15 times a raised to the power 2. All right, so after doing that, okay, after doing that, we have 15 times a raised to the power 2 times b. All right, look at considering here, we say 15 will cancel 15, 1, and that is gone. Okay, remember the division rule. Okay, when you have identical bases divided together like this. Okay, you have identical bases divided together like this. What do? We take them to a common base and subtract their powers. All right, so we have a here, will go over, will go up, okay, to meet here, but with a minus sign. So a, all right, 7, take it to a common base and subtract minus 2, okay, times, take this to a common base and subtract b 8 minus 1. Remember, this has a power of 1, okay, invisible 1. So we have that a 7 minus 2 is equal to 5. So we have a raised to the power 5 times, okay, 8 minus 1, we have 7. Okay, and we have a raised to the power 5 times b raised to the power 7 is equal to a raised to the power 5 b raised to the power 7.